So, hi everyone. Thank you for joining our colloquium series this month. Today, I'm excited to introduce to you Irene Lo. I hope I pronounced your name correctly, Irene. Irene is an assistant professor in the Department of Management Science and Engineering at Stanford University. Our research builds on tools from algorithms and economics to design matching markets and assignment processes with a focus on public sector and non-profit applications. She's especially interested in resource allocation in the education, the environment, and the developing world. And more broadly, she is socially responsible. She's interested in socially responsible operation research. She currently co-organized the mechanism designed for social good research initiatives, and she is co-launching the related conference series of equity and access in algorithms, mechanical design, and optimization. Today, Irene will be talking about market design for social good using math, algorithms, and economics to address social problems. Thank you so much for joining us today, Irene. We're excited to learn from you. You may start.
Thank you so much for having me, Teju, and for everyone who is watching now or watching remotely now or later. And I'm going to go ahead and share my slides and get started. Great. And you can see my slides?
Yes. Thank you.
Wonderful. Great. Well, thank you again for inviting me to be here. I'm very excited to speak with you all. And I'll be talking today about market design for social good using algorithms and economics to address social problems. And my goal today is sort of to highlight for all of you a little bit of how this particular area of research called market design brings together economic ideas into a lot of problems that you might think of as first as algorithmic or AI problems where you're just trying to learn some things about some people. But I'll talk about how a market view can also be very helpful in these settings. Okay. So since I'm going to talk about a market view, I should describe what I mean by a market. So what is a market and what is market design? And so when I say market, you might think of a farmer's market. You might think of a stock market, the New York Stock Exchange. Some of you who've heard of market design before might also think of, say, ad auctions. So when I'm looking for a throw pillow on Google, you can see that they put up a lot of ads at the top. Or you might have heard of the FCC spectrum auctions. But for the purposes of today, I want you to think of a market as a place where there are things and there are people who want the things. And the market design asks how we set the rules of the marketplace so that the right things go to the right people. Okay, and so why does this use both economics and AI, computer science algorithms? Well, first, obviously, from economics is all about markets. And so we can learn a lot about how to think about markets in general. We can learn a lot about how to think about equilibria, which is often where prices in markets come from. We can also learn about game theory and how to think about incentives and how people will react to the rules that we've set up in our marketplace. But then from a computational perspective, well, I said before that a market is a place where we're trying to figure out how to get things to people. And so resource allocation algorithms, matching and assignment algorithms are very much related to how we might think about scaling a marketplace and making decisions in a large marketplace. And today I'm also going to point out how a lot of applications of market design require some kind of prediction or decision support in order to support how we can set up the marketplace in order to predict how people might respond to the marketplace. And then what is market design for social good? Well, market design for social good is taking together the market design approach where we combine economics, computer science, operations research, and applying it to markets where we're assigning students to schools or jobs, workers to jobs, or volunteers to tasks or volunteers to donations. And what I'm going to do today is tell you all a little bit about two specific examples of market design I've been working on. One is in the education space, so assigning students to public schools, and the other is in agricultural platforms, so thinking about providing further access to market information in agricultural supply chains. So let me go ahead and tell you about this first project. I'm calling this School Choice and Diversity in San Francisco. And this is joint work with Itai Shlagi, Max Ullman, Kaylee Mentzer, Juliette Love, Louvel Busuit, and Adonis Pugh, who are all San Francisco Unified School District, which organizes all of the public schools in San Francisco. So what is school choice? The goal of school choice is to let students choose where they go to school. So I don't know how schooling was decided where you live. Where I grew up in Australia, it was very common just to go to your neighborhood school, right? So you, depending on where you live, you just kind of go to the closest school. But in a lot of cities in the US, they actually use something called school choice. And why do they use school choice? Well, they're in a city where there are a lot of schools that are nearby and available for students to go. And so one idea is that choice allows families to express preferences. Families might know better than sort of some kind of central planner which school is best for them. And so school choice allows them to say, well, I would rather go to this kind of school because it's an art school or a science school, or I'd rather go to that kind of school because of extracurriculars. Okay. A secondary goal that's often described in school choice policymaking is to disentangle neighborhood and school segregation. And so I'll show you a little bit more about what I mean by that in just one moment. Okay. But to make things more concrete, here is the example of school choice in San Francisco. So our problem here is we want to assign students to public schools in the San Francisco Unified School District. And I have for you here a map of the city of San Francisco. And you can see the red dots are the elementary schools. Okay. And so there's a lot of schools, a lot of students. There's about 5,000 students per year applying to over 70 programs. And so here, one of the goals is to let families express their preferences through choice. But now let me tell you a little bit about the other goal, which is disentangling neighborhood and school segregation. Okay, so San Francisco, like a lot of cities in the US, has a long history of racial segregation going back to the Jim Crow laws and basically enforced and redlining, so enforced separation of where people of different descent lived, specifically those of African descent. And so if you look at the city of San Francisco, you can see that those of African descent comprise only 5% of the school-going student population, but they all live kind of down here, right, in the southeast corner of the city. And so these patterns of neighborhood segregation come from a long history of racial segregation of both neighborhoods and schools. In 1954, Brown versus Board ruled that school segregation is unconstitutional, but you can see this is from 2010 census block data. Segregation at neighborhood and school levels still occurs quite a lot in many cities in the US. And this is particularly concerning because there's very recent research that shows that large racial achievement gaps tend to occur or are correlated with when there is concentration of historically underrepresented racial groups at high poverty schools. And so ostensibly, another of the goals of choice in the city of San Francisco is to disentangle neighborhood and school segregation. It might be that the neighborhoods are segregated, but the argument is, well, if we let people choose wherever they want to go to school, then it doesn't matter where you live. We can give everyone equal opportunity everywhere in the city. Okay. But what was going on in San Francisco is that they noticed that this was not actually occurring. Okay, so in December 2018, the Board of Education of the San Francisco Unified School District launched a redesign of elementary student assignment to achieve predictability, proximity, diversity, and equity of access. Okay. And so let's say I asked you to sort of design who gets to go to school in San Francisco. What kind of ideas might you have? The first obvious idea that's used in a lot of places is neighborhood assignment. And so in San Francisco, we see here the problem is that racial and socioeconomic segregation of neighborhoods would then be persisted into schools. And so the second idea that's been used for over a decade in San Francisco is district-wide choice. And the problems with this system were that even though it was meant to give students opportunities to go anywhere they wanted in the district, in practice, it was really hard for them to do so because the system was unpredictable and opaque. So they had no idea which schools they would be able to get into. There were strategic issues where people were trying to game the system by lying about where they wanted to go or moving into advantageous areas. And also, as you see in these two maps, choice did not help with diversity. And so what I'm showing on the left here is a socioeconomic need as measured by a percentage of students who are eligible for free or reduced price lunch. Okay, so you can see that the intensity of the red shading is coming from the attendance areas. So these attendance areas, these boundaries, which contain the highest percentage of students with socioeconomic need. And then if you look at what was happening after school choice, I've also highlighted here, these brown dots are the schools with the highest percent of students with high socioeconomic need. So you can see sort of the brown dots are lying exactly where the dark neighborhoods are. Similarly, if we look at concentrations of historically underserved minorities, this is those who are African American, Latinx, with Pacific Islander descent. Again, we see the same pattern from the Southeast to the Northwest, where there's a lot of concentration of those ethnic groups here in the Southeast, and that's also where the schools that end up with the highest percent of historically underserved minorities. And so what I'm going to briefly outline for you today is how AI and market design together helped address this issue. Yes, Teju.
I wanted to confirm, the dots signify each neighborhood, right?
Oh yeah, good question. So the dots, you can see that there are colored dots and also gray dots. The dots signify schools.
Okay.
And so what I've done is I've overlaid on top of the neighborhoods, the schools in each neighborhood. And you can see that the color of the dot represents whether it's in the 50% of schools with more students of high socioeconomic need or the 50% of schools, these gray dots, with less students of high socioeconomic need.
Thank you.
Yeah, good question, good clarification. Okay. And so I'll briefly outline for you how we can use AI tools and market design together for this particular problem. In our case, so we helped the district develop a policy decision support tool. We also suggested new assignment policies that were informed by AI. And then we performed simulations using data from the district, and together the district came up with a policy proposal. So I'll tell you briefly about each of those. So first, just a little bit of background on the typical approach to school choice. School choice theory and then also school choice practice usually uses this approach called mechanism design. Okay, mechanism design might seem like a foreign word, but the concept is pretty simple. The concept is I'm going to take my input to my problem, that's student preferences, as well as priorities at the schools for neighborhood priority, sibling priority, as well as how much space or capacity the schools have. I'm going to use this as an input to a mechanism. And a mechanism is just an algorithm with strategic input. Okay, so that's how the algorithms and economics are coming together. I'm starting with an algorithm, and then I'm asking, well, if everyone is playing a game when they put input into this algorithm, how do we expect the output to look? And then finally in school choice, well, what is the output? The output is an assignment. So an assignment of students to schools. Now, typically in school choice, we might think of both preferences and also school priorities as being strategic. So maybe families will try to game the system, and maybe schools will also try to game the system. But in the case of San Francisco, we're going to think of just preferences as the strategic options. And the goal of mechanism design is to design this part, design this algorithm, taking into account that families will be strategic, but still letting them choose schools. In addition, we're also going to use the priorities to guide the allocation. So I'm not going to go into too much detail about mechanisms, but I just want to tell you about two of them. One of them is called deferred acceptance, and one of them is called top trading cycles, and they're designed so that they're what we call strategy proof. It means that no matter how anyone else reports, you get your best possible assignment by saying truthfully what's your first rank school, your second rank school, your third rank school, so on and so forth.
I have a small question, please.
Yes, please take it.
How you decide on priorities? Is it based on the, like, is it individual that is deciding on priorities, or this is where you talked about the socioeconomic status of students?
Yeah, really good question. Why don't I come back to that in 2 slides? But the short answer is that in San Francisco, the districts and the schools decide on the priorities. Okay, and I'll tell you in 2 slides how exactly they decided on priorities. Okay, but these are the typical things that you can do in school choice. You can decide on priorities, and you can decide on the mechanism, and you can also try to restrict choice. And so I'll tell you all about all of those in just a moment. Okay. But before I do that, let me tell you about this policy decision support tool that we built with the district. So if we're trying to simulate what might happen with an alternative policy that takes into account all these pieces, then we need a decision support tool that also captures all of these pieces. And so in our decision support tool, the first piece was choice modeling. This enables us to do counterfactual simulation because we can predict counterfactual school choice. By counterfactual, I just mean what would happen? How would people choose if we change the effects of their choices? And so here, this was where we used quite a lot of AI. We used prediction models such as rank ordered logit to predict utilities that students might have from schools depending on their individual characteristics as well as the school's characteristics. There were some really interesting patterns that we saw in choice data, that people from different racial backgrounds often had different lengths of school lists. So for example, the average school length list for those from the African American community was about 3 schools. They would list just 3 programs, whereas some families from more well-resourced backgrounds were listing 60 to 70 different programs. So really listing everything in the district. And so in our choice modeling, we also predicted how many schools would you list. Finally, there's also people who don't stay in a public school system, they go to private school. And we also predict based on your characteristics, whether you'll stay in the system or go to private school. So a lot of prediction problems that are involved in making sure this decision support tool is really giving us a good sense of what will happen if we change the policy. The next piece is just simulating everything that's going on. So simulating the policy changes, simulating any changes we make to the mechanism. On top of that, we also looked at the output of all of these simulations and we evaluated them in terms of metrics capturing the district goals of predictability, proximity, and diversity, equity of choice, and equity of access. And then finally, we also are in the process of building a visualization tool that will help us to communicate assignment trade-offs. We already have one that we use internally in the district to evaluate how these policies trade off between district goals. But what we're doing now is building an external community tool to illustrate all of these trade-offs for members of the community and to gather their input on how they think the district should make a decision. And so I think this is a different component of AI, sort of the HCI world, where you're thinking about, well, how do I help people understand this big socio-technical system, this big algorithmic system that affects where they get to go to school. So those are the pieces of our policy decision support tool. And now I can go back to Teju, your question about policies and the pieces in them. So the first piece of the policy is priorities. And what priorities do, as you mentioned, Teju, is they give priority to target student populations, or they can also prioritize different students at different schools, depending on if they live closer, if they have a sibling at the school. And what I've shown you here is how the district was previously prioritizing students. So there are light blue dots and there are dark blue dots. And the dark blue dots are the students who were selected by the district as being from historically more census blocks with more need. Okay, and so they looked at 2010 census data. They looked at demographic information and also academic achievement of all the different census blocks. And they picked the 20%, which they thought they wanted to give more choice, more access to schooling resources, because historically they had less access and were not performing as well in the schools. So this was how they used to determine priorities. But when we were designing the new policy, we sort of had free rein to also redesign the priorities. And this is important because priorities are the typical tool that people think about using in school choice to sort of make things more equitable or make things more diverse at every school. The second tool or lever that we considered was using zones. And the idea here is, instead of letting everyone choose between all 70 different programs in the district, we're going to restrict you to choose within a geographic zone. So for example, if you live in the orange zone, then you can only choose a school from the orange zone. And so this helped us to restrict, so that people were choosing from between 10 to 12 different programs instead of from between 70 something different programs. And finally, we also considered something called reserves. And the idea of reserves is we're going to reserve seats at each school for different student populations. So here, maybe say in the zone, a third of them are yellow dots, a third of them are purple stripes, and a third of them are blue triangles. Then we'll reserve 1/3 of the seats at the school for each of those groups of students. And so what we did with the district was we simulated thousands of combinations of all three policy levers. In fact, we also ran optimization heuristics for choosing how to draw these zone boundaries. And so there is both optimization and simulation involved in sort of sifting through all of these potential policies and choosing a small number. And so what I'm going to do now is show you the results of that small number. I'm going to show you the results of 4 policies. I'm going to show you the results of 4 policies on San Francisco kindergarten admissions data. So what I'm going to show you is based on student preferences and school priorities and all rounds of admissions from 2013 to 2020, as well as enrollment the following year. And we're going to focus just on student data from the 2018-2019 round of admissions, but we have data for all these other years as well, and we've also verified on those years. And how we're going to use this data is we're going to look at preferences. So we're going to use a predicted choice model using the 2018-2019 preferences, as well as the predicted choice model is using all years of data, as well as the actual stated choices from the 2018-2019 school year. And then we also look at different groups of students. We look at what happens if we only consider students who enter in the first round, as well as students who enter in all of the rounds. And so by rounds, I just mean that student assignment happens at a couple of times during the year. There's a main round that happens in sort of February, March, but there are some students who miss that deadline and they are assigned maybe in June or in August instead. And this is important because often the students who miss the first round are those who are less informed about the student assignment system. They don't know as much what's going on. They're often from these historically underserved groups. And so those students can actually change some of the results. And so we did simulations both for just round one students as well as all students. Okay. And so here's what we found. We looked at 4 different policies, one using just zones to restrict choice, one using zones and reserves. So we restrict choice within the zone. And also at every school, we set aside seats for different students. One was using just priorities. So coming up with a priority that was better than the previously used priority. And this last column here was the 2018-2019 assignment. So just comparing ourselves to what happened historically. And here we have measures of the district goals of proximity, predictability, diversity, and we also measured choice. Even though it wasn't a district goal, it's very important. It's one of the goals of school choice to give choice. And so there's a lot of numbers here and a lot of metrics. I'm not going to go into detail about all of them, but let me just highlight a few things for you. First of all, whoops, here we go. So here are some colors. On each row, green means it's doing better in that row, and red means it's not doing better in that row. Okay. And so if we look at just priorities, let's say we come up with better priorities that are able to prioritize more students, better target the students who need priority, then what we see is that the district can reach some of its diversity goals. So if we look at schools that are within 15% of the district's socioeconomic average, before we only had 44% of schools within 15%, and that's less than half the schools. But with priorities, we can now have almost 80% of schools within those bounds. And if we look at concentration of historically underrepresented minorities at these high socioeconomic need schools, we can also see there the percentage goes down from 29% to 12%. But with priorities, what we see as the problem of giving district-wide choice, that proximity is not doing very well, because you can go anywhere in the district, people have to travel pretty far. And the district did not like this because it meant that it was more difficult for them to provide transportation and bus routes to serve all the families in the district. And so we look at zones, what we see if we use just zones is that choice leads to resegregation. Okay, so we can have diverse zones, but once we let people choose within the zones, our diversity metrics are not looking so good. But if we use reserves, now all of a sudden, all of these entries here are green. So our zones with reserves allow us to achieve district diversity goals. So you can see 81% of schools are within 15% of the district's socioeconomic average. And also the concentration of historically underrepresented minorities at high socioeconomic need schools has also gone down. But we're also able to achieve goals of proximity and predictability. Okay? Because the zones are much smaller, there's much fewer schools that you have to consider. And so you don't have to travel as far, and you know your chances better at each school.
I have a small question, please.
Yes, please, Teju.
Well, that means like for the zones plus reserve, what we are able to achieve is that in case the zone, for zone only, if you had only put students in zones, but they don't want that zone, they want another zone, the reserve can cover them, right? Or would this be how?
Yeah, what's going on is that in, let's say, the orange zone over here, there are maybe 12 schools in the orange zone. And so even though there's, say, pretty representative group of students in the zone, maybe all of the African-American students go to one school in the South, and all of the Latinx students go to 2 schools in the North. So they're segregating within the zones. Does that make sense?
Yeah.
Yeah, so because there's still choice within the zone, people are self-segregating when they choose. But if we put in the reserves, then we, at every school, can have a better mix of students from different backgrounds.
Yeah, that was what I was just thinking from the student perspective. What if you don't even want to go to school within your zone? What if you want to go to other zone and you can afford the transportation and everything? If the policy was determining my eligibility based on zone, then definitely I wouldn't be happy with the choice, right? Because then I'm not able to go to other schools. Yeah, but
that's a really good point. So we do look at choice. We look at the percentage of students who get one of their top 3 ranked schools. Okay. You can see originally it was about 80% of students. With just zones, it goes down a little bit to 76%. And with zones and reserves, it goes all the way down to 67%. Okay, so there's this extra 13% of students who are not getting one of their top 3 choices. They might be pretty unhappy. And so a couple of things the district is doing about that. First, because the zones are now small, the district can help provide transportation.
Okay.
And so maybe you didn't like it before because you didn't know how to get there, but now you have a bus. The second thing is, well, because now there's a smaller number of schools that are associated with each community, it's easier to get communities to go together to the same school, right? So maybe you wouldn't want to go there if you're going by yourself, but it's you and say 3 other of your neighbors all going to the same school. And that's much easier to do in this new zone-based system. But yeah, you raised a really good question about, well, what does the community think about all of this? And so let me talk about that in 2 slides. First, let me be specific about the policy that was proposed. The proposed policy was to use zones with reserves, because you saw it did so well in the previous slide. We use medium-sized zones to balance between predictability, proximity, and diversity. And we use contiguous zones to enable design of bus routes. And one of the target metrics is to have 85% of schools within 15% of district socioeconomic average. And then the second tool is they're going to use equity priorities to improve outcomes for target populations, including homeless students in foster care. And this policy recommendation was jointly proposed by us and the district staff, and it was passed by the Board of Education last year in 2020, not December 2020. Okay. But going back to Teja's question, what do parents think about this policy? Okay, first, there's still a lot of decisions to be made in the policy. So there are zones and reserves, and so the exact zones have not been chosen. All the policy says is some zones will be used to restrict choice. Okay, so the question of, well, do I like the schools that are going to be in my zone? We don't know the answer to that question yet because the zones haven't been chosen. And so we're working with the district on bringing together community input and putting together the zone boundaries. The second thing is choosing equity priorities. So we have evidence that the historical equity priorities were they're put together in 2010, they're no longer necessarily targeting the right students. And so that's something we're also working on with the district. And so for the zone choosing, we are also putting together a visualization tool that will help the community really think about the effects of the zone boundaries on them and the families around them. And so the district is setting up sort of a phase of 2 years, or one really targeted year right now of community engagement to put together the zone boundaries. And then finally, moving forward, we also have to set up a way to monitor and evaluate, see if the policy is actually achieving its goals, see if the policy is actually addressing community needs. And so this piece over here, I think on the community engagement, there's a whole sort of ecosystem that will be supporting that at the district. So to your question, Teju, of, well, what if families don't like the schools that are available to them? Part of the community engagement is also talking about how we can all be investing in the nearby schools. So that you might not like how a school looks now, but the district has examples of schools that grew and changed significantly even in the span of 2 to 3 years, right? So you might not like the look of your schools now, but let's come together as a community to build into some of these schools. And maybe you'll like more of the schools in your zone if everyone in your zone comes together to support them. And then, as I mentioned before, Teju, also the idea of, well, the zones are smaller now. And so we can use some algorithmic tricks to increase the probability that you'll be going to schools together with others in your neighborhood. And so maybe you didn't want to go to school by yourself, but there are a couple of families all going together from your neighborhood. And that might make it more attractive for you as well. In addition, another reason it's really important to have family buy-in is that the policy helps improve representation, diverse representation at the schools. But diversity is not the same as integration, right? You really want all the families to be interacting with each other. You want the teachers to be supporting students from diverse backgrounds. And so, as I said, the district is really emphasizing community engaged design. And so so far, we've co-designed the policy with district board and staff, but really what we want to be focusing now is on community engagement. So is this policy achieving the district goals and also family goals as the families understand them? Do the families understand what's going on with the different choice levers and how that helps achieve the goals? How do the families think about restricting choice? Do they think we restrict choice too much? Or is there opportunity to still develop and rank highly the schools that are close to them in their zone? And so moving from diversity to integration, we're moving now into a phase of large-scale community engagement for visioning what these zones could look like and for educating and engaging families and how they can make such a policy work for them. And as I said, we really need community buy-in for the policy. And we also need community support of all the schools in the zone if we want to ensure that every school is a school that people want to go to. Another point is that at all of these schools, there are often different programs. So there's like a language program, there's a general education program, there's a special education program. And so to go from diversity to integration, we also have to think about other things like how can we be educating teachers? How can we bring together students from all of these different programs so they're actually interacting with each other instead of just siloed in their different programs? How can we provide resources, transportation resources, capacity resources, teacher resources to support this change?
I have a small question, please.
Yes, please.
So it's not like the schools are the same like in each zone, right? Like what I mean is that some zones might be expensive more than other zones, right? Do they pay school fees or something?
Yeah, so public schools don't have fees, but there is something very strange in the American schooling system, which is that funding for schools is tied to local property taxes. So if you live in a richer neighborhood, your school will have more money. And if the school is in a poorer neighborhood, the school will have less money. And so that's one way the district can help support. They can help provide more resources to the schools that are in lower income neighborhoods. And something else that we did when drawing the zones is we looked at measures of socioeconomic status when trying to come up with diverse zones. And we also looked at measures of school performance. So how is the school doing on suspension, absenteeism, test scores, improvement in all of these factors. And we try to also balance the zones in terms of these different measures of how resourced the schools are and how much they can support the students. Yeah, so that's a good question.
So if that's the case, if it's like if you're in a richer neighborhood, the schools in the zone will be doing a lot better. They also get public funding, right? Is it equally distributed? Do the governments give all of the schools in the zone like the same amounts, or do they give the funding based on the socio-economic status of the zone? So what I'm thinking is that if by default within the rich zone, the local community would give you more money, then maybe government should give less to those community and then put more money in the low income community, or I don't know.
Yeah, that's a really good point. And so this is complicated by the fact that there's funding from federal sources, state government, and as well as local government. And so at the higher levels of government, the funding is per student, and it's the same at any school. So depending on how many students enroll in your school, that's how much funding you get. And so the district, which is sort of local funding, is trying to help overcome this by providing more district resources to the schools that are under-enrolled in less resourced areas of the district.
That's sort of like a cat and mouse game, right? You have low students. Like how do you give the incentive? How do you make it balance? It's such a hard problem.
Yeah, and you're exactly right. This is, one of the big issues with public school funding in the US. We weren't trying to really solve that problem with this project, but it's definitely, everyone kind of knows the issue is there. And so you have to work around it for now while it's there. And definitely, I very much hope that the system will change.
Thank you, Irene.
Yeah. Okay, so just tying this back to how I describe market design to you. Market design in this case asks how we set the rules of school assignment. So the right schools are assigned to the right mix of students. Okay, so students are going to the schools they want to go to overall, but also you're supporting diversity and integration at the schools. And so the tools we use from economics were game theory and mechanism design, but also you can see from an AI perspective, we had to predict choice, we had to optimize zones, and then from a computational perspective, we also had to simulate all of these different algorithms and policies. Now, moving ahead, I think there are a lot of problems that are adjacent to AI that are really interesting in this space. And so one question is, as I mentioned before, there are students from certain populations who don't list a lot of schools, right? They put 1 to 3 schools on their list. And so what that often means is that they're unassigned or they're assigned to a school that they didn't list when we do choice. And so one question is, can we help recommend schools? Right? Can we come up with a recommendation tool that helps people put more schools in their list, and so they're more likely to get assigned to a school that they actually thought about and thought they might want to go to. Another question is transportation and bus routes. As I said, now the zones are smaller, we can provide more bus routes, so we have to now think about, where should we put these bus routes? As we've been touching on in this discussion with Teju, we also have to think about fair resource allocation. So where are all the resources in the district going? And how can we improve this? And it's not just money per student, right? There's also where are the experienced teachers going? Where are the buses? Where are the good facilities with more space for students? And so there's lots of resources. Where are the language programs being assigned? Yes, Teju?
Yes. I'm sorry. Okay, so I just wanted to make a comment. You talked about some students having like small, they don't have a lot of schools in their list. And I was just wondering, could it be that they think that if they have less school, they'll have higher chances of getting into maybe one of the 3 schools?
Yeah. So there's been some community engagement to understand why families put fewer schools. And actually the primary reasons are, one, they think they'll get into one of the schools in their list, not because they think a shorter list helps them, but because they think the schools that they put are not very popular, right? Oh. So that's one thing. Another reason is they just don't have the time to look into more schools. Okay? They're like, it takes a lot of time and resources to look into more schools. My neighborhood school is good enough. Let me just list that. Mm-hmm. And then the third piece is also generally kind of like what you're saying, just not understanding how the system works and thinking, well, I just get assigned to my neighborhood school, right? So I'll just put it on my list. Mm-hmm. So there are lots of factors, but I think that specific way of gaming, I haven't really heard that from parents so much. And then the last piece, which I touched on quite a bit, is thinking about community engagement from an HCI perspective. So how do we help all different members of the community sort of understand this big algorithmic backend of the school assignment system, and not so much understanding the assignment system itself, but understanding how the decisions and the policy will affect everyone in the district. Okay, so now I have 5 minutes, so I'm going to very quickly tell you about how we can think about using these tools to improve information in agricultural supply chains. And so here, when I think about agricultural supply chains or supply chains in general, I'm thinking of a system of organizations, people, activity, resources, and information involved in moving a product or service from a supplier to a customer. And so in the case of many agricultural supply chains, you start with the raw product, but then it's processed, it's transported, it's refined, and then turned into products for the end user. And one issue in agricultural supply chains is that they're often informal. So they're created through word of mouth processes. They don't use written contracts or digitized contracts. And it's very hard to regulate or provide oversight on how these supply chains perform because there aren't digital records of all of these agreements. Okay. And so what's the opportunity here? The opportunity is that there's often inefficiencies from outdated or inaccurate information because there's no sort of written record of this information. And so there's also this opportunity that we can now use information technology to provide people with more information. And so I'm just going to tell you very briefly about this one set of projects we have looking at palm fruit in rural Indonesia. So palm oil is one of the most widely produced vegetable oils worldwide. In 2019, there was globally demand for 75 million tons of palm oil. That's almost an order of magnitude more than olive oil, for example. It's been used in 50% of packaged products, including chocolates, cosmetics, toothpaste, plastics. And one of the reasons that there's a lot of academic interest in the palm oil supply chain is because there's also one of the leading causes of deforestation. So smallholder farmers clearing land to be able to plant more oil palm trees. And so we focused on Indonesia because Indonesia is one of the largest sources of global production. More than 53% of global production of palm oil is from Indonesia. Palm oil production accounts for $23 billion in foreign exchange revenues in Indonesia each year. And also smallholder farmers own or manage a significant proportion of oil palm plantation, and they comprise about 30% of the labor force. So there's really an opportunity to help the smallholder farmers in this context. But of course, Indonesia is not the only place we could consider. So for example, in Nigeria, palm oil production Nigeria once accounted for 43% of world production of palm oil. And currently 80% of the production that does occur in Nigeria comes from smallholder farmers. So also an opportunity to think about palm oil supply chain in Nigeria. Okay, and so just to highlight the work that we're doing there, what we were focusing on this first mile of the supply chain. And what I mean by the first mile is the smallholder farmers who grow the fruit, the transportation middlemen who transport the fruit to the mills that process the fruit. And together with my collaborators, we found quite a lot of opportunities for AI and market design in this space. And so I've been working mostly on market information, but you can also think about transportation logistics, giving farmers more information on which roads they should be taking, especially if there are, say, weather conditions. And so you really need a lot of prediction and fast route optimization for this problem. And then there are also a lot of apps looking at crop management. So here I have some examples from AgriPredict, which Teju you might know, which look at how can we predict which crops you should be growing. Can we try to detect using images whether there are any diseases in the crops or ways that you can be helping the crops to grow better. And so what I did is I looked at some questions in market information. So specifically, we say there's limited access to information because all the information comes through these informal links. So you can see that some sellers are linked to just one buyer. So they basically have no choice. They always just sell to the same place. But there's opportunities. You can see that there's price dispersion. So if they went to some of these different places, they might be able to get a better price. And so we ask, how can we design some of these platforms like PemPem, which I'm working with, also Reuters Market Live, Asal, and Kudu, in providing more of this market information. I don't have time to tell you about these two research problems today, but basically our approach is trying to crowdsource information from market participants via an information sharing platform. And that raises a number of theoretical questions. We might try to crowdsource information from the middlemen. And so the research question there is, how do we crowdsource information from competing middlemen? Or we might try to have processors post their own information. And the question there is, how do we make sure that when they post their own information, they don't collude and they don't try to set really prices that are good for them, but bad for the farmers. And all of this is supported also by large-scale fieldwork in Indonesia. Okay, and so for this setting, market design asks how we set the rules so that the right prices are shown to the right people to ensure that everyone wants to share information and that there's no collusion from the more powerful processors. And so from economics, we use game theory and collusion, but also in computer science and operations research, actually the fieldwork, we need to predict names, because often there are people use lots of different names to refer to the same person or to refer to the same buyer. And so if we want to see who has connections where, there's some prediction that needs to be done for names. Something I didn't include on this slide is the way that we collect information on the app is from people taking pictures of receipts. And so there's a lot of machine learning going from the picture of the receipt to sort of text recognition and trying to extract the information from the receipt. From a general computational perspective and operations research perspective, we have to model buyer contracts and the effects of that on the supply chain, as well as thinking about optimizing information disclosure, who gets to see what information. Okay. I think I'm over time, so I'm not going to go into these other issues, but just say that those are just two examples of the many ways that you can use market design for social good, and also to give a plug for mechanism design for social good that thinks about much broader applications of mechanisms for applications ranging from healthcare to online labor markets to developing nations that Teju is involved in. One last plug, if you are interested in this general space of questions, you can always feel free to email me, or you can check out our upcoming conference in October, the inaugural ACM conference on equity and access and algorithms, mechanisms, and optimization. Will be highlighting things like in this talk, where techniques from algorithms, optimization, and mechanism design, along with insights from other disciplines, can help improve equity and access to opportunity for historically disadvantaged and underserved communities. So there's a chance in both the EMO conference and in the MD4SG initiative to connect with other researchers also working on this space. Okay, so that's all I have to share with you today, and thank you so much for being here with me.
Thank you so much, Irene. Like, this is so very insightful for me personally, and thank you for sharing your work with us. And yes, everyone, please go check out MD4SG and make sure to check out the developing MD4SG Dev, which is the one I'm also co-organizing, so that you can join us. We talk about all of this problem with mechanism designs, and think a lot about on the underserved community. So if anyone have questions, please can you pop in to ask your question, or just write in the chat as well if you have any question. Or maybe comments. If you're also watching from YouTube, you can also write on YouTube chat.
And as I said before, if you're a bit shy now or you think of something later, you can feel free to reach me at email. I'm at ilo@stanford.edu.
Okay, definitely. So I guess we'll wait 2 more minutes or 1 more minute if anyone have questions. If not, I'm happy to just continue to chat with you and maybe talk about the last the other projects, which is on the agriculture part and everything. So how has been the market, the market research, and how do you come up with these policies? How do you go about meeting with the farmers, deciding on what works for them, and all the back and forth, just getting this right?
Yeah, really good question, Teju. So I highlighted 3 opportunities. There's access to market information, there's transportation logistics, and there was crop and yield management. And so, excuse me one moment. Actually, I have a slide on this. Let me put up the slide.
Okay.
So my collaborator, Joanne Desaker, engaged in large-scale fieldwork for 1.5 years before even posing any of these research problems. Okay, so what she did was she did data collection and community engagement. So 4,000 farmer surveys, middleman surveys, also surveying the farm locations, and also coming up with the links between the farmers and the middlemen and looking at GPS routes. Excuse me. And so based on this 1.5 years of just being in the community, asking them questions about their connections, asking their questions about their needs, that's where she was able to identify these sort of 3 areas of focus. Actually, the 2 primary ones that came up in the Indonesian context was that they wanted to know, well, how should I drive if there's weather, so the road is unusable, or there's a landslide, some condition that makes the road difficult to use. And they also wanted to have access to more information. So what happens in the supply chain right now is that the processors have a list of their loyal sellers, and every day they update their price. And when they update their price, they'll text those loyal sellers. And so they're sending these SMS messages to get price information. And that's the only way that people are getting price information. That was the graph that I showed you earlier, where everyone has very few connections. And so from that engagement, that's how my collaborator was able to tell that they really wanted more market information. They felt like, that the sellers, the buyers they were selling to sort of had a monopoly on the prices, because they really only knew 1 or 2 prices. And so my collaborator is still engaged in large scale field work in the area. They have a field team of about 9 to 10 field workers who continue to run these surveys. They also help farmers understand how to use the app. So they have app training sessions. And I was meant to join her on a field trip in 2020, but obviously neither of us went in 2020. And so that's a little bit of a peek into the field work that's going on there.
Thank you, Irene. Dina has a question. She asked, what incentive do you give the farmers to send information on the app?
Yeah, another really good question. Actually, I have a slide on that too. So why don't I put this slide up? So here's the slide. The idea is, so we want to crowdsource market information and incentivize people to give valuable information. And they might not be incentivized because they're competing with the people they share information with, right? And so the incentive we use is we use information to incentivize sharing of information. So on the app right now, actually, let me take a step back. On the app right now, they use money to incentivize. They say, if you share a piece of information, we'll pay you, this amount of money per piece of information. And this is getting very expensive because the app has grown significantly since they first launched it at the end of 2018. And so our research is looking at, well, are there other ways to incentivize sharing? And basically, we thought about using conditional information disclosure. So share today, see tomorrow, right? If you share now, we'll pay you back with more information in the future. And so basically what we're doing right now is trying to come up with a way to implement, operationalize this on the platform so that we can move from paying people to sharing information with people as an incentive. And the other thing we had to consider was using partial information disclosure to balance the effect so that there aren't some people who benefit more than others. And so we're kind of working through right now, maybe we can use some kind of token-based system, maybe we can use some kind of subscription system where if you share today, we'll keep track of your sharing and use that to give you more access to information in the future.
Maybe one last question from me. Thank you, Irene. Is that how do you, like the veracity of the information, how do you verify that what they share is true?
Yeah, really good question. One of the first order questions in an information sharing setting. So right now, a lot of the truthfulness of information sharing comes from 2 aspects. First, we require people to upload a physical receipt. So they have to send a picture of the receipt showing that they sold at the mill that day, and the receipt also has the price on it. And that's how we collect price information. Another thing is that there is monitoring and verification. And so there is a field team, and so they do spot checks that people are providing correct information. And so they say, if you're caught giving false information, then you'll be banned from the platform for 3 months, right? And so there's really sort of a community trust that people are putting accurate information and that it's not acceptable to put false information. Well, that's definitely another research question we've been thinking about. You know, are there sort of more incentive-based ways that are a little bit sort of more nuanced, more designed, that don't just rely on sort of goodwill, right? Yeah, and also with the receipts, other people have pointed out that, so a colleague of mine pointed out that, say, in India, people will fabricate these kinds of receipts all the time. And so how do you make sure that people are not just making up information to put on the app? So really good question.
Well, thank you so much for the wonderful explanation, and thank you everyone for joining today's colloquium. I hope you've learned something, and if you're watching in the future, I hope that you would learn a lot. I definitely learned so much. Thank you so much, Irene, for sharing with us. And as she said, you can reach out to her. If you have any question, you should definitely also check out MD4SG, and there's always a community there to join whatever you're interested in. So, and with that, we're wrapping up for today. Thank you everyone for joining, and